Hi, welcome back to nuk234. This is class number 3 of Immersive VR Compositing in Nuke. And I'm your professor, Daniel Smith, and here we have our troll that's inspired by the movie Snow White and the Huntsman. And you can see he's such a fun design, and he is rigged here for our basic previs. We're going to be able to jiggle his head around, rotate his arm, make him reach out for us. It's pretty basic stuff. So we need to start putting him into our environment and get everything designed around him. So the first order of business is to put this into a container that's going to basically be the room in which the shot exists, kind of like a set or a sound stage. So I'm going to zoom out, and we're going to create a kind of like a generic box. Let's make it about that big, and we'll set the height. Let's see. Make it about that tall. We might have to make it a little bit bigger in a little bit, but the main thing is to, at this point, because this is previs and we're going to be visualizing this, is I want to see inside the box, but I don't want to see the outside walls. So I'm going to go to the attribute editor in Maya, and we're going to open up our render stats. We're going to make the cube not double-sided, and we're going to flip the polynormals so they're inside out, kind of like that. And our event is going to happen in a screen over here on the corner. So we're going to put him over here. And we may have to make this a little bit bigger, but the next thing we need to do is bring in the shape of our screen. And I provided a asset, so hit import, and I want you to import the screen.obj. This is the actual movie screen that we're going to be using. So you can see that about how big it is. We're going to take our box and we're going to move this to about right about there. We're going to put them right in the corner like that. All right. And I'm also going to create a couple other boxes here. Let's create one right about here. And we're going to create another box right about here. And this box is kind of interesting because it's going to act as a divider wall. Our ride is going to enter in here. We're going to come up to the screen and we're going to move past him and back down this way. And this box adds not only as a visual barrier, but it can house some of the technicalities of the ride, including like the projector that's going to illuminate this movie screen. So it's a good thing to have. Now let's also go ahead and open up our Hypershade, and I want you to put on the screen, let's graph that network. That screen currently has a surface shader. Surface shaders are great because what they're going to do is they're going to illuminate the surface of that without shading. So if you were to put like a blend or something like that on, it's going to have some shading on it. But with a surface shader, the texture will be pixel for pixel exactly the same. So I'm going to bring in a file node. Oops. Just grab those. There we go. And we're going to connect it to inside the calibration chart folder. I have a image right here, which is a alignment chart. And we're going to pull that up and we're going to take its out color and connect it to the color right here. So that way we get that. Nice. All right. So one thing about this screen object that's really critically important, and this is going to become even more important later, is its UV layout. If we look at the UVs right now, you can see that the UVs go straight up to the edge. They are completely contained within 0 to 1 space. And that's really critical for this. Make sure that is exactly what's happening. And the sizing of this was such that it's creating an exact circle in the middle without distortion, because it's a slightly curved screen. All right. Now I have my troll slightly positioned outside the screen and behind the screen, and that's purposeful because in the end, that's what we're trying to make it feel like, that he's breaking out of the screen, reaching out at us, trying to grab us as we ride past. So as far as previs goes, that's okay that he breaks that fourth wall. So let's, before we move forward, I'm going to hit save. Make sure you save early, save often. And we're going to go take a look at the ride base now. All right, this is a ride vehicle. A ride vehicle is a basic generic version of a Stewart platform on basically what's come down to it is like a couple of wheels that are going to follow a track. So we have a track, and this will be able to move forward, back. We can rotate it, and it will rotate and steer along that path. But that's pretty much all we're going to do today, is just kind of move it along a path past the screen. Later on, we're going to go up to here, and we're going to start moving this portion of the base and using some rotation, some yaw, some heave, some surge, and get this thing to feel much more like a ride. Now, the rigging on this is such that you can overextend the limits, and you know, that's not going to be very realistic. So we have to be a little bit careful of like how far we push this thing. And we want to be gentle. We don't want to kill the people riding along in our ride. So what I'm going to do is we're going to go back to our other scene. So I'm going to open that up, and we're going to import this in, and we're going to design a ride path. So let's do a file import, and we're going to import the motion base. And let's grab the motion base controller, and we'll bring it out. And we can see about how big it is right here. All right. And what we're going to do is we're going to go into curves, and we're going to create some curves right here. And we're going to build a path similar to this that takes our ride along, our motion base along for a ride. And we're going to create that curve. And let's go ahead and edit that. So let's move this along here. There we go. And got a couple little control points that need to be adjusted. There we go. And we probably want to keep most of this flat. So you can see I got a couple points a little high right there. All right, so what we want to do is we want to take the controller of the motion base and control click the curve. And now that we have both of those selected, I'm going to go up to our animation menu and go to constrain motion path, attach to motion path, and let's pull up the options box. And right here, we're going to make sure that our up axis is on the Y, and that is checked on follow and time slider. and our time slider is going from 1 to 200. So let's expand that out. Let's give ourselves about 400 frames. Make sure that's going. And we're going to make sure that that's going, and it looks okay, so let's hit attach. All right? So now we can see that it is following that path. Now it's following it kind of backwards. So what I'm going to do is I'm going to take my curve, and we're going to go back to modeling, and we're going to go to curves, and we're going to rebuild our curves with reversing its direction. So we reverse the direction, and now it starts at the beginning. Got a little weird pirouette there. I'm sure that's a control point, and we'll see that it flows along the path. All right. Now we're gonna go back through, and I'm gonna take the animation on the rotation of the base down here, and we're going to, as it goes through here, I'm going to keyframe it so it has some rotational value, so it's always pointing towards the screen right here, because we want it to go past the screen. And I'm going to fix that curve and tweak that a little bit. There's going to be a lot of tweaks, so I'm going to kind of pause the video and get the curve smoothed out and add some keyframes to make that go. And the only other thing that I want to point out is on the motion path right here, this is what gets animated, is the U value. So if we go into our graph editor, and we pull up this position here, okay, motion path U value. This is basically a translation curve. So this curve will control the overall movement on here. So if I take this, you can see it's controlling its position on the path. What's really cool about this is if you bend some of these curves upwards and create peaks and valleys, what will happen is this will go forward and backwards depending on whether the curve is up or down. So just by like doing this right here, you can see that now our animation is actually flowing backwards. So you can make it pause by plateauing it, and et cetera, et cetera. So there's a lot of really great control here. So like I said, I'm going to pause the video, I'm going to do some animation tweaks, and I'm going to get the timing just right on this. All right, so I've got my animation all figured out, and we've got our little timings there, and I ended up extruding the rail to make the spline curve not just look like a spline curve, but give it some actual geometry that would look nice in the scene. So now we need to put our camera actually in the ride vehicle, in the center of the ride vehicle. So let's create a camera, create new camera, and let's rename this our shot cam. And we're going to take that shot cam and we're going to put it right there in the middle. Now we need to get this geometry here, so let's find it in the stack. Here we go. And we're gonna, you can see I've already got a shot cam in there, but we're gonna delete him, and we're gonna take this shot cam and we're gonna simply parent it to that geometry, so it's right there. So if I select it, we're gonna zero this out. So 0, 0, 0. And scale this down right here. All right, so you can see the camera's right down there at the middle, and we're going to put this up at about 24 units above, which is going to put it right there in the center of the pod. And this is going to be our rendering camera. And you can see it's a little off kilter, so let's put that at 180. And there we go. That's perfect. Now, before we move our timeline, and remember we're on frame 155, you can see that it's going to carry it along with us right there, okay? So that is just simply parenting. And so now that we have our camera right there and it's pointed in the right direction, now we can take a look from our camera. And we can see what our shot's going to look like. And you can see that this is going to be very difficult to render. Why? Because it's so freaking close. So first of all, let's open up the attribute editor for our camera. And we are going to use a different lens. We're going to use like a 24mm lens, a little bit wider, which is great, but you can see it's still too wide. Well, it's not too wide, it's too, the image is just, it's overwhelming the screen. So we kind of need to take a look at what we're going to be rendering. So let's select our camera and let's look at our camera settings and look at the resolution gate and see what the area that we're actually going to be rendering, which is this border right here. And what we need to do is we need to be able to see the entire screen. We're going to have to render a 4K image to get a 2K image, because we're going to have to shrink down the render view considerably to be able to work it into Nuke and to be able to flatten out these transformations, you know, create the VDI, the view dependent imagery that is going to make this shot work. So we need to make this much larger. So I'm going to go to the camera attributes and we're going to go to shot cam shape and we're going to open up the film back. And we're going to go down to these values right here, this post scale. It's going to translate, move our camera, and we're going to use this value right here to enlarge our frame. And if we put a value of like 0.2 in here, there we go, and we reduce the window frame, you can see what it's actually doing. 0.3, 0.1, and it's enlarging the frame quite a bit, but the actual, it's almost like a zoom lens. It's actually not changing the distortion. If we punch in on this, it's almost identical. 0.9, 0.8, 0.7, 0.6, 0.4, 0.3. You can kind of see how the values are staying consistent, that there's not parallax that's being introduced. So what we want to do is we want to scrub through our animation and we want to get it the minimal amount of enlargement or shrinkage, I should say, that we need. So I'm looking at the corner of our screen right here and you see it kind of goes off right there. So on frame 243, that's probably the limit. I'm going to probably have to make this a little bit smaller. So I'm going to go to 1.9. Okay, so that's pretty good. And it looks like the screen is in view the entire time. Excellent. Okay, so now that we've got this correctly set up, the next step is to do a render out of Maya so we can bring this into Nuke and double check our settings. Now, one thing I want to do is at the beginning of the shot, we're traveling down this corridor and you're barely seeing the screen. And we're going to do some stuff with that in a later class. But for right now, I'm going to hide this wall. So that way, when we render, we get the entirety of that screen. And you can kind of see that this part right here clips ever so slightly in there. So I'm going to take this wall and we're just going to back it down a little bit, so that way I just want to make sure I'm seeing that whole wall during my shot. You know, it's like, I want to be very careful of that. So maybe, you know what, we'll hide that too. So that way we're getting just that screen. All right. Now what we need to do is we need to, well, I'm going to save early often, is we want to take this and render it out. So we're gonna do a hardware render. So I'm going to set up hardware 2.0 and we're going to render this out. And 400 frames, we're going to make sure that we are using the shot cam. And we're going to render it at 4K, so 3840 by 2160. And the whole idea is that we're rendering at 4K so that, and we're also, when we do the full render for the high-res assets and everything for our shot, these renders are going to be at 4K minimal, so that way we can get a 2K render for the actual screen out of that, you know, give or take. So I'm going to just go ahead and I'm going to hit rendering, and I'm going to send this to a batch render in the background. And then we're going to also, we need to get out the geometry of the screen, very important, and the camera. So we already have the screen, so that's simple as exporting selection and making sure you save it as a OBJ. Nuke can take OBJs. And now we need to get the camera. And the camera is part of this motion base. So one thing that I'm going to do here is I'm going to select all of our objects right here in the motion base. And we're going to save it out as an Alembic cache. So I'm going to export selection to Alembic. And we're going to make sure that it's using the time slider. That's all good. Excellent. So we're going to export the selection. And we're going to see motion base and export the selection. All right. And it says it has a ancestor relationship. That's bad. Okay, so it didn't do it. Oh yeah, we need sometimes with these dynamic relationships, you might want to do a safety net of baking out the keyframes. So I'm just gonna bake the animation so that way the animation keys are baked, because it is being animated by the motion path. There's also keyframes on the main controller and all the way down the line. So now that that's all baked out, select the top of the hierarchy, which is going to have everything including the camera, and do the Alembic cache. There we go. Now the Alembic is processing. Perfect. All right, so one other thing that I should mention is when we look through the camera, you can see that the screen, the ride base is intruding on the screen a little bit. So something that I like to do is I will select that and we'll hide it. And because it's in a hierarchy, it doesn't like to be hidden the traditional ways. So one thing that you can do is go under the attributes and go down to object display and uncheck visibility to hide it. So we can hide it that way. And another thing that I'm going to do is, it's very critical on what we do in Nuke to make sure that this screen is lined up to the screen in Nuke. And this checkerboard on the edge has a lot to be desired as far as like detecting the very edge and limits of the screen. So one thing that I like to do is I opened up that image in Photoshop and I made a different version that you'll find in your folder which has the underscore green line. And what happens is it puts a very fine green pixel outline that's only 2 pixels thick around the entire border. And that really helps with the next process. So we're going to render this out and we're going to jump over to Nuke. All right, so now we're back in Nuke and we're going to go open to our project settings. Our project is going to be based in 1080, but we're going to, for other reasons, we're going to have to go up to 4K. So we're going to leave it at a 1080 and our frame range is 1 to 400. Let's lock that range. And I'm going to set up the script directory button, which allows us to have some dynamic attributes in our loaders. So let's do the read, and we're going to read in our imagery that we just had rendered. So this was just simply play blasted essentially from our ride path moving through past the screen. And what you can see here is exactly what it's supposed to be, where we're getting this render from the point of view of our camera, and it's got a lot of distortion, but that's the way it would really look. But we would never see it in this very wide window frame. So what we need to do is we need to put it back into and extract it off of that background. So let's do that. So let's take that, and we need to bring in our geometry. So let's do a read geo, and our geometry is going to be the screen. So let's bring in that movie screen. There we go. So screen object, open that up, and the dynamic properties for the loader that we did before, let me just remind you of that, where we did this. This is so our paths don't have to be absolute. You can see that, you know, this is reading off my X drive for my FX PhD stuff, but we're going to just kind of drop that out, put a dot node there, and that way it reads directly from that. But you can see that that has errored. Why is it errored? Because this is a Python command that says we'll read the directory in which the nuke script resides, and currently we don't have a nuke script. So we need to save our script out. So let's save this out. And class 3. And we'll save this as our work in progress file. So whip. So now that this is saved, let's clear it out. We're going to read it back in. And notice that the loader does not error out. The loader is set to .images screen because it's relative to the path by which where this file lives. And that's the way I give you the files. So that way, if you open up your nuke script with the same hierarchy that is contained in the zip folder, it will work. You won't have to repath everything. So here's a screen object. We're going to do the same thing right here. It's dot like that. All right. So if I view the screen object, hit F for fit, and there it is. It's in the same location that it was in our Maya file. And now what we need to do is we need to project that image onto that screen. So we need our camera. Our camera was saved in the Alembic. So let's go grab that. And let's do a geometry, read geo. And this one's going to take a little while. When we do this one, say cache, Alembic, motion base.abc. This is going to read it. I'm going to create all in one node. But this literally will probably take, I mean, I've got an 8-core machine and it takes a good like 30 seconds for this to process. So let's hold, I'm going to pause the video for a moment and wait for it to load. And don't worry, it will load for you too. It's not crashing, but it does seem like it's crashing because it takes a while to load this. All right, so if it's loaded, you're going to be seeing a lot of nodes. So it brings in a locator for all the different things that we used in the rig, and we can get rid of these. None of these are important. So you can delete those nodes. And basically what you want is the camera and the motion-based geometry. Now, the motion-based geometry is going to have a similar fit when I take that and do that to a dot like that, but just hit cancel and it won't try to reload it. And you'll have that, and you can see we've got full animated geometry inside of Nuke of our motion base. So that's going to be really handy, but we're going to set this off to the side and just going to turn it off for right now. And that's the best way to deal with that. What we really need is our shot cam. So let's rename this camera to shot cam, just like before, and turn off read from file. We don't want to read from file anymore. It's all the data that's relevant, translate, rotate, scale, our focal length, our aperture, all that kind of stuff is there and relevant and perfect. So turn that off, and that way it won't be referencing back to that Alembic file. And you can see there's our camera. It's moving just like the way the shot was designed to. Great. So now what I want to do is I want to project this image using this camera onto this piece of geometry. So let's grab a shader, a Project 3D, and we're going to connect our camera, our image, and our geometry right there. Perfect. So what's going to happen now is let's take a look from the point of view of the camera and lock our camera. And what's happening is, well, something terrible. Okay. What you can see is that the image is way different and it does not line up in any way, shape, or form. Now, one of the problems is, well, our screen size is a little too small. We actually need to go back to our preferences and make our default size Ultra 4K. And I forgot about that part because at this point, you can't change this resolution. We can later with a scanline render, but we can't change this resolution that it's going to use as its default. And that's really important for this projector to be able to do that. So let's save our comp, clear it, and reload it. And that's going to kind of force Nuke into refreshing itself so that way when we look through the shot cam and lock it, see now it's Ultra 4K. Now that gave us a lot more screen real estate, but our image is still wrong. And what we need to do is remember what we did in Maya, where we scaled down the scene to 0.19. Well, this is where that little green line thing comes in so important, because we have to take our shot camera and let's make a copy of this and put it off to the side. And we'll just call this one like ride cam. So we know that that's what the rider camera actually is. We need to change this one to reflect what we changed in Maya. And it's under the projection options, and right here it's going to be Windows scale, and it's just like what we did in Maya, except the values are not the same. If I put in 0.19, you're going to see that in Nuke it kind of like shrinks it even more, but it basically kind of puts it back into the original render. You know, it's making it small. But we don't want that at all. What we want to do is we want to go in. We don't want to go out. So we actually have to increase our values. And it's got to be quite a bit higher. And that's where having that green line is going to be really, really important, because it's not just like a value of 1 or a value of 2, a value of 3 or 4. It's closer to 5. See how as I go up, 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 it crops in on that. If I go to 6, oh, we went too far. So, and let's put the other value at 5. So you see how that shape is now coming into there. So this is really important. So one of the things that I'm going to do is I'm going to go into my preferences, and we're going to switch our texture size in our viewer to a much higher texture size. And so that way we can really see that pixel line. And we're going to roll our options. So we got 5.2, 5.3 is too big, 5.2.6. There we go. All right. So I'm just watching that line. And now let's put the same value in the V, 5.2.6. Perfect. Now you see how that worked? Now if this worked correctly, you should be able to go to any frame and see that exact image with that faint green outline all the way around your geometry as it's being projected onto there. Awesome. So let's undock our camera and actually look at this screen and see what's actually happening here. As we play through our sequence, you can see the shot cam is moving past the screen, but the imagery on it, you can see, is changing because it's being projected from here. So now we have all these files right. I'm going to switch my texture size down a little bit lower so that way it plays back a little more interactively. And what we're going to do is we need to render this out. So let's grab a scanline render. We're going to render this object. We're going to render it from no camera. And the reason why we don't need a camera is because we're going to render it from its UVs. That's why we were talking about back in Maya that those UVs are important. So we're going to select UV, and there we go. Now it's unwrapped that distorted image, just like last week. But the resolution is too high. Ultra 4K is not our deliverable. So what we're going to do is we're going to create a constant, and we're going to attach the background of the scanline render to that constant, and that's going to tell the render to render at HD. There we go. Perfect. So now, as we go through, you're going to see some slight resolution changes where things are going to look a little softer, a little grainier, because literally we're taking this tiny image right here to look like this. So that's why this side is sharper and this side is a bit softer. Now we can play a little bit with some of the filters to try to get a slightly better resolution image. And we're going to look at some methods to improve that in the final imagery. But for right now, this will be fine. What I want you to do is we're going to write this out. And we're going to write it out as a JPEG sequence at 0.75, low quality, because the main reason is that we're going to map it back on, and we want to have fast interactivity. So I'm going to go ahead and I'm going to hit render on that, and I'm going to check in a second. All right, sweet. So let's bring in that render, and let's bring it back in here. We're going to call it the VDI test, and we're going to just hit play, and we can see how that's going to look. And you can see that it's essentially just like last week, where we're getting these distortions that are dependent on our view, VDI. And as we get closer to the screen, we see the resolution get much better. And now we're pulling away from the screen, going away, and you can see it getting softer, but the image is staying stable. So the whole idea here is that this image now becomes a movie that gets projected or rear projected onto that screen surface in the ride. And when you are seeing it from that same angle, it will look correct. So let's go ahead and create that exact same sort of thing. So let's take our image, put it back onto a screen object, and we're going to create a scene node. And bring the camera and the object together. And let's close all these panels so it refreshes and brings in our imagery. All right, so now you can see that this pretty much looks identical to the way it was in Maya, where it was a fully 3D scene, except we are now seeing it as a two-dimensional image on a screen from the point of view from which it was rendered, continuously updating. Which is really, really cool. So if I switch this to our ride cam, which doesn't have the window scale, this is essentially going to give you the point of view from the motion base without any head tilt or movement. And you can see that it works really great, but we have this tremendous field of view that fills our peripheral. And that's the whole point. So this way we have a HD movie screen. We're moving past it. Now, don't even get me started with the, well, what if you want it to be a 4K or a 3K render or a 10K render on that screen? Well, then you have to render much, much more. But we have some strategies to make that render a little bit more reasonable, and we'll get into that in a moment. The only other thing I want to show you here right now is I'm going to bring in a piece of geometry for the room that we were in, just to help us visualize and see the connective tissue between what we were doing earlier in Maya to Nuke. So there we go. And I'm going to put a checkerboard on here and just kind of connect it together. So that way, this is also part of the visualization, is so that we see our walls, we see our floor, we turn off the grid, and we can see everything the way it's meant to be, right? And if we go back to our shot cam, that's the way the render was, and we can toggle that back to the ride cam. We'll save that out. All right, so here we are, we're back in Maya, and you now understand how we take the imagery that we are generating and translate it directly over to the way it needs to be in Nuke so we can project it. But the key to this shot is not that it's a big grid on a movie screen, but something far more dimensional. And what we're going to create is basically this screen is no longer going to be a screen, but a entranceway into a diorama in which this troll lives. So let's basically do that right now. I've got this scene all set up already, and we're going to take this room and we're going to replace this room with a much different room. So let's unhide that. And I want you to see this. I went ahead and I built some tunnels on the edges, and we built this giant cave inside of the screen, basically. So this area is where our shot is actually going to be. We're going to construct our shot back here, right at the edge of this movie screen. And everything is going to play out as we move by this screen and see through the hole. Now, the hole isn't there right now, so what we need to do is we need to actually take this and create the inverse of that. And I'm going to hide the screen. So let's hide that and put this up. And this is called the screen mask. And this mask is basically creating the hole into that environment. And it's in the exact same place as the screen, except it's got a black hole shader or a surface shader on it that will render black to the RGB and black to the alpha channel. So that way, anything that's behind it that isn't there will be not rendered. So when we're really far away, well, let's look, and we're off here, anything that is not appearing through the hole will be black, and hopefully will save some render time for it not to have to render those pixels. So that's what this black mask is doing right here, right? But now we have this tremendous amount of space back here, which we're going to populate with a forest. So let's put the forest in. There we go. And instant forest. Yay. Okay. So there's our forest, and you're going to see the forest gives us lots and lots of parallax and opportunity for some really interesting moments. Now, the forest is going to be a few layers of geometric trees, and then I'm also going to render another pass with more trees around a ring here, and then we're going to also be shooting a 360-degree image that's going to be going into the far background to just fill anything else. All right. So we have our forest, we have our troll, and let's add a little bit of lighting. And let's see, let's switch our lighting, use all lights, there we go. So now I've got a little bit of lighting for our previs. And we're going to also switch out our troll for an animated version of the troll. So this is a really terrible animation, I apologize, but it's exactly what I needed to produce to give to my animator so he can go ahead and perform the animation. So our troll is basically sitting down, curled up like a rock, and as we get close, he springs up, he swings his arm out of the screen at the audience, and then lumbers back into the forest. So it's a pretty quick shot, but it's pretty thrilling. And if we look at this from the perspective view here, we can see that three-dimensionally, when he goes and reaches out of the screen and swings at us, that is going to feel like he is punching us square in the face. And hopefully my animator is going to get some finger action where the hand is going to flex outward a little bit further than my crude animation. So that's going to just reach out and grab us and be pretty freaking awesome. So we are going to now render another version of our shot, just like we did before. We're going to render it using hardware render and get this particular part of the shot taken care of. So I'm going to hit render on that, and we're going to jump back into Nuke and bring this version of it in too. All right, so we're back in Nuke. Awesome. And let's just go ahead and read that. All right, so we have our forest scene right here, and you can see that we've got him all rendered. And we're just going to replace this just like that, and we will create another write node to render out a version of the forest instead. And the main reason we're doing this is these PNGs that are coming in and going through this process. It's pretty taxing. This render will probably take about 5 minutes to process, and it just doesn't help for real time. And now we're going to bring our render in. So right here, we're going to bring in our VDI forest. And we're going to do the exact same thing. We'll just substitute it over here, and then we'll hit play, and we'll let it buffer. And there we go. Now check that out. Now we've got that render going on with our little previs, and as we round the corner and we come up to the movie screen, notice how it looks just like it's three-dimensional, like you could just crawl through that wall and go straight into there, because it's constantly updating depending on our view, VDI imagery. So what we're going to do is I'm going to switch this from the shot camera to what our ride cam would look like, and kind of give that idea of like, okay, this is what it's going to be like. Is we're going to come in, we're going to see this troll, we're going to be like, what is that? Oh my God. Ah, it's reaching out. It's going to grab me. No. All right. Thrilling. Yay. So this is pretty awesome. I'm really thrilled with how this is turning out. And let's take one little look with our default camera so we can see how that imagery is distorting and compressing. And you don't even notice it, how the background is compressing into the foreground and twisting and turning and changing directions. It's pretty freaking awesome. That's all for this week, and what we're going to be doing is we're going to be taking a closer look at the little fine details and getting this back into taking our previs, getting it back into Maya, substituting a couple things. We're going to probably tweak the motion just a little tiny bit, and we're going to start rendering our layers. We're going to start putting this shot together the way it's meant to be. So I'm going to take a look at like the lighting and breaking out render layers, and going forward, classes 4 through 7 are going to be a bulk of rendering out layers, putting them together into Nuke, and making this shot look really, really awesome. And then we're going to be coming back into this environment to create a 360-degree camera, so we can export this out to our various platforms and utilize it with an Oculus and Android and iPhone devices, and be able to experience this in true VR. So that's going to be a lot of fun. I'm really excited about all that we've done so far, and the concepts and the integration of these sorts of shots is really, really cool. So if you have any questions, hit me up on the forums and let me know what you think. So thank you so much.